Hello and welcome to the new style GCSEs. This is the Edexcel GCSE grades 9 through 1 paper. This is paper 1 MA1/1F. It's the first paper in the foundation tier, and we're picking up in question 29, which reads, describe fully the single transformation that maps triangle A onto triangle B. This is actually more straightforward than it looks. What we have here is a rotation. The reason we know it's a rotation, if we look, with the short side is 2 units and the long side is 3 units. The short side of triangle B is 2 units, the long side is 3 units, so this is not any kind of enlargement. It's not a translation, because a translation, the orientation would be the same. In this case, the long side is parallel to the x-axis, but in this one the long side is parallel to the y-axis, so it's not a translation. No single translation could ever put this triangle here. It's not a reflection, because the same distance away from the reflecting surface all the points would have to be. So if it was a reflection, this point here that's 2 up from the x-axis would have to be 2 down from the x-axis if the x-axis was the reflecting surface. But I can't think of any way you could put a mirror, or any orientation you could put a mirror that would make this look like this. That leaves us with rotation. So this is a rotation. So the first thing we do is we write down rotation. Okay, so a rotation has to be around a point, and the key to remember is that every point on triangle A will be the same distance from the point of where it's rotated as the same distance on triangle B. So if we pick a point here, I like this point, we can actually notice that if this is coordinate 1, 2, this here is coordinate 2, 1. So this point at the edge of the short leg of the triangle, where it meets the hypotenuse away from the 90-degree angle, this point corresponds to this point. So if we draw a straight line here, we can actually see, well, we can visually see, you could use a ruler if you want, but you can notice this goes across 2 and up 1 and down 1, and this goes up 2 and across 1. So this is the same distance from the origin. So the rotation is about the origin. So this is a rotation about I'm not going to say the origin, I'm going to say about the point 0, 0. It's basically because I didn't fancy drawing the word origin with my trackball. Okay, so what angle, I'm going to say through. Well, visually this just looks like a right angle. You can use a set square or a protractor to confirm if you like, but I think this is very clearly a right angle. So we're looking at 90 degrees. And lastly, the direction of the rotation. This is going clockwise. If you imagine this y-axis is pointing to 12 o'clock and this x-axis is pointing to 3 o'clock, this is going the same way round that the hands on a clock would go. So this is clockwise. I'm writing on the area where it says don't write. Okay, so our answer is rotation about the point 0, 0 through 90 degrees clockwise, or rotation about the origin through 90 degrees clockwise, or rotation 90 degrees clockwise through the origin, something like that. I hope that was helpful, and I'll see you in the next video.